Okay, YouTube, in this video we're going to share the basic premises of compound interest when it comes to finances. And the whole idea behind it is simply this. If you give, say a lending institution $100, say to put into a savings account, we'll go with that. It's a very safe investment, so there's not a lot of risk, but they're using your money to give to other people. So they pay you a certain percentage of interest on your money. So let's just say they do this, say, once a month. And if I put $100 in there, let's say I get a really good rate, they give me a 1% rate, that means that the very next month what I'm going to have in there is $101. And the reason why is because, well, 1% of 100 is $1, so they're going to pay me 1% of what I had. Now I have $101. The thing here is this: if we're to take this now, 101, and find 10% of that, 101 times 0.10, here's my 10%. Or sorry, my 1%. So 101 times 0.01, 0.01 there. 1.01. Now if I add that on to, now the next month I have this. I have 102 and a penny. So I have a little bit more than what I had the month before, and they're going to give me now 1% of that on top of that, which just continues to cause this amount to grow each month. So of course my money's going to go up, but the idea is that it's going to compound, and it compounds exponentially. Okay, so it doesn't do it very quickly, especially with the 1% rate, but I will tell you this: it does it significantly enough that we want to pay attention to it. So we say we often receive interest that accrues in the form of a percentage or a rate. Okay, so we say common compounding intervals include things like annually. When we hear annually, it means that once a year they're going to take that rate and add it on to what your initial amount was. We usually call that the principal amount. We have biannually, which is twice a year, or sorry, every 2 years, where semi-annually is every half a year, so twice a year. Quarterly is 4 times a year, and monthly, of course, is 12 times a year. You even do weekly, okay? It says the formula for the amount of overall money, Y, so this is our overall money here, so we say overall amount is our Y value there. It compounds N times per year, so we say N is the number of compoundings per year, okay? How many times it compounds a year? So for instance, biannually would be a half a time a year because it's once every 2 years. Or semi-annually is twice a year, so N would be 2. So we say the overall amount of money Y compounding N times per year for T years. So T is time in years. With an initial amount A. So we say A here. A is this principal. Principal, if I spell it right here, principal amount, or what you started with, okay? And at a given percentage rate R, where we write R as a decimal here, so we say R is the rate, okay? Rate. So essentially, we have this formula right here that will allow us to both model and calculate some values here. So let's just run through really quickly how we might use this model. This, by the way, this model, Y equals initial amount times 1 plus R over N to the N times T. I just want everybody to know that this is our basic growth model, where we've kind of expanded the definitions a little bit, but we had this to begin with, where X and time are kind of the same thing here. B in this 1 plus R over N, that's our growth factor, okay, growth factor, and then we have an initial amount. So when we look at this up here, it says we invest $500 that our grandmother gave us as a graduation gift into a slush fund that accrues interest annually at a rate of 5%. I think the best thing to do is to start off by saying things like, well, I know that my A value, or my initial amount, is 500. I was given that my rate is 5%. So that 5% I'm also going to take, and I'm going to write that as a decimal. So I know my rate and my initial amount. And what I'm asked to do here says, write a model to represent the overall money there is after T years. Okay, so when we write this model, I need to know some things here. I know A, I know my R value, and I don't know T, and that's okay, because when we write a model, we tend to leave Y and X the way they are, and everything else in between, we let them assume values. So T is fine. We say, well, do I know N? N, recall that N is the number of compoundings that we have a year, and we said that this was annually. So I could say that this is very fair to say that N is 1 time per year. So our model would be the total amount of money we have is equal to the 500 initial dollars that we had times, in parentheses, 1 plus r. Now our r value we must write as a decimal over n. Our n value is 1, and this is all to the power of n, which is 1, times t. So this is our model. We love this. I'm going to clean this up actually. We're going to say that y equals 500. If I took 0.05 divided by 1, it would be 0.05. And if I took 0.05 plus 1, I'd get 1.05. So here's our growth model right here, 1.05 to the 1 times t, so to the t. Now this thing right here, if we were to go graph this, we could say, well, give me a time at which my money reaches a certain amount, or give me a certain amount at a given time, okay? So it says use our equation to calculate how much money we would have if we let the money sit around for 5 years. So the thing I want to indicate to everybody here is this. I was given a value to substitute into this model, but I was given a time. So we must be asking for a y value or an amount of money. So we say 500 times 1.05, and this is to the 5-year total, tally there. So if I open up my calculator here and I say that the first thing I want to do is this exponent, we'd say 1.05 to the power of 5. So it becomes this, and then we'll take that times 500, and we get 638.14. So y is approximately 638.14. So we could roughly say that we'd have about that amount of money in there after 5 years. And that's kind of neat that it's just going to start at 500, and at this rate, compounding, once a year, you would have made $138 just by not touching it, because it would have grown on its own growth. Okay, so we say, well, let's do this again, but I want to assume the slush fund compounds semi-annually. So we're going to have all of the same initial values except for semi-annually now means that n is going to be equal to 2. So our model then becomes this: y equals my initial amount times 1 plus r, which is our 0.05, our 5%, over 2, and this is to the 2t. So this one, a little bit harder to clean up. We say 0.05 divided by 2 is 0.025, and so we would say that this is the same thing as 500. If you wanted to do this, we say 1.025. You could clean up the inside. You don't have to. This is to the 2t. So we want to ask the same question, how about after 5 years? And so if I said y at 5 years, we could even say that this is a function. So we say f of 5 would be 500, 1.025 to the 2 times 5. So here's what we're going to need to do. Again, with the calculator, we're going to need this. But we're going to have to simplify the exponent first, which are 2 times 5 is 10. We're going to say 1.025 to the power of 10 is this new value. We're going to take this times 500. So if it compounds twice every year instead of once every year, we see we get a little bit more money because it compounded more times. So we say 640.04. So approximately in dollars, $640.04. And again, if we did this, over 10 years instead of 5 years, and we do this monthly, now I've switched the time on us. The time I'm plugging in is 10 years, and I'm assuming that it's monthly. So we'd say that this is 12 times a year. So we'd say y equals 500, 1 plus 0.05 to the n, or over n, 12. And now we have this to the nt. So we say 12 times years is 10. So we have a fair amount of simplification to do here, as a matter of fact. I'm going to leave this exponent as what it is, because I know that's 120. I need to get what's in here first. So 0.05 needs to be divided by 12 first. And then we'll take that plus 1. So this is what we have as a growth factor. Now we are taking this to the power of 120, which we get this new base, times this 500 out front now. So we get 823.50. So approximately 823.50. And this is true at t equals 10 years. And if it's compounded monthly, we would have made $323.50 just by letting our money sit there. So hopefully that grows a little bit faster than what inflation is doing. But you make some money because it compounds on itself. Cheers.